Good morning, guys. Today we're going to be graphing from all kinds of equations. This is going to include standard form, this is going to include some of the equations that we saw day one, and even going a step further to multi-step converting into slope-intercept form. Our first activity is kind of a review of graphing just regular linear equations in slope-intercept form. You're actually finding the error, so you're finding, fixing, and justifying. For the first one, it says Lainey was asked to graph the line y equals 4/3 x minus 2. Lainey graphed the line below and made a common error. Describe Lainey's error and then graph the line correctly on the grid. Same for the next one. It talks about Janine and how she graphed the line x equals 1, and then how Zach graphed the line y equals 4 minus 2x. Okay. There is an error in all three of these, so we need to find the error, describe the error, graph the line correctly on the grid. Okay. So go ahead and pause the video and try your best. Remember, this is rough draft thinking, so it is totally okay to make mistakes and fix them later. We learn math by doing, not by seeing others do it, so it's really, really important for you to try this first and then have me go over it after. Okay, so go ahead and pause, and I will see you shortly. Okay, so for this first one, Lainey was asked to graph the equation y equals 4/3 x minus 2. We know that if an equation is in y equals mx plus b form, m is our slope, b is our y-intercept. So for this equation, 4/3 is our slope, and -2 is our y-intercept. Okay, when we graph an equation, we always want to start at -2, and it looks like Lainey does that. Our slope of 4/3, remember, slope is rise over run. So we should see Lainey graphing up 4 and over 3, or right 3. So if I look, I see a point here and I see a point here. So when I'm checking her slope, it looks like she's instead going up 3 and over 4. So Lainey actually graphed a slope of 4/3 instead of, or 3/4 instead of 4/3. So we need to write that down. So Lainey graphed a slope of 3/4 instead of 4/3. So this is an easy fix. We just need to, I'm going to do this in a different color so that it sticks out. We're going to start at -2. She did the y-intercept perfectly, but we need to go up 4 over 3 instead of up 3 over 4. So I'm going to count up 4, right 3, up 4, right 3, up 4, right 3. And I'm going to keep that pattern going the opposite direction. And then I'm going to connect all of my points. It's important for our line to go all the way across the screen, just like Lainey's does. Okay, so that is number 1. For number 2, Janine was asked to graph the line x equals 1. Janine graphed the line below and made a common error, describe Janine's error, and graph the line correctly on the grid. So when we talk about x equals a number and y equals a number, one is horizontal and one is vertical. X equals a number is going to contain all of the points where that x coordinate is that number. The y equals a number is going to be a line that contains all of the values where y is equal to that number, the y coordinate. So if I'm graphing the line x equals 1, I want to plot as many points as I can that is going to have 1 as the x coordinate. And if I'm looking, x equals 1 is right here. So all of these points along this line have x coordinates of 1, right? This is the point 1, 1, this is the point 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, and we can also go in the opposite direction. So it looks like Janine graphed the line y equals 1 instead of x equals 1. So we can say Janine graphed the line y equals 1 instead of x equals 1. Okay, and then we can kind of just draw our line a little bit better. Again, I'm going to change to a different color so we can see a little bit better. And it really contains all of these points because these are all of the points where the x value is equal to 1 or the x coordinate is 1. Okay. Another thing that might help you guys remember this is that x is always a vertical line and y equals is always a horizontal line. And it's kind of the opposite of each other's axes, okay? For the third one, Zach was asked to graph the line y equals 4 minus 2x. Zach graphed the line below and made a common error. Describe Zach's error and then graph the line correctly on the grid. So our equation is y equals 4 minus 2x. So we know that our slope is always attached to the x. It's always the coefficient to x. So our slope in this equation is -2. Our y-intercept is 4. Okay, so it looks like what they did is swapped the y-intercept and the slope because it looks like their y-intercept is at -2 and they went up 4 and over 1. So they kind of made two errors here. So we're going to have to be very specific when we are describing our error. So Zach confused the slope and the y-intercept and to be more specific, we can say he graphed the line y equals 4x minus 2, to be even more specific. So we got to fix this line. So we got to do a slope of -2, a y-intercept of 4. So I'm going to go ahead and plot my y-intercept, always our first step. And for a slope of -2, it needs to be decreasing. So I need to go down 2 and write 1 instead of up 2 and write 1. And we're going to continue graphing these points. And I'm going to continue the pattern the other way. Just like that. Okay. So that is our first activity, kind of a review of graphing, getting us warmed up, kind of doing some analyzing right off the bat. And now we're going to dive into some new content with graphing from standard form. Yesterday we worked on how to solve for y given an equation in standard form. Now we're going to take it a step further, and from our converted equation we're going to graph those. So for our first one, it says graph the equation below. Be ready to discuss your ideas with the class. So because this is in standard form, I can't graph it because I have no idea what the slope and the y-intercept is as of this moment. Instead of just going ahead and graphing this, that would be incorrect. I would have to put it into slope-intercept form. So if you guys remember yesterday, we drew a line down our middle and then circled our y to kind of remind ourselves what we're isolating. And remember, it's kind of like a two-step equation. We need to get rid of our x's first, then divide by our coefficient of y. So we're going to subtract 4x on both sides of our equation first. I'm left with 2y on the left side of the equation. And on the right side of the equation, I can't combine these terms because one is an 8, one's a constant, and one is a variable term, -4x's, right? I can't put together apples and oranges. I can say I have this many oranges, this many apples, but I can't combine them into one thing. So that's kind of what we're doing. We're saying we have -4x's and we have 8 regular ones. Okay, now I still have a coefficient to my y, so it's saying 2 groups of y would be this. I only need 1 y. I need to know what just y equals. So I'm going to divide every single term by 2. If we look, we see -4 divided by 2 is going to give us -2x. And then 8 divided by 2 is going to give us 4. Okay? I want you to pause here, catch up on any writing that you need to, and go ahead and graph this equation. Okay, if you guys notice, we really just kind of did this with our find, fix, and justify. Okay, so we just graphed this type of equation. So y equals 4 minus 2x is the same as 4x plus 2y. Props to you if you figured out that connection without me pointing it out to you. So we're going to graph it the exact same way. We're going to plot our y-intercept at 0, 4. We're going to go down 2 over 1 because every time our x increases by 1, our y value is decreasing by 2. And we're going to connect all of our points. Beautiful. Okay, so this is really, really important for us to get our equation in this y equals form. Because if I just went ahead and said, oh, my slope is 4, my y-intercept is 8, because it kind of looks like it would be looking up here, but it's not. If we solve for y, we see y is actually equal to -2x plus 4. So it's super important to put that equation into slope-intercept form before we graph. Okay? So write down how to graph an equation that is not written in slope-intercept form in the space below. I would like you to brainstorm an idea of what we can write here. Think about the problem that we just did and think about maybe an absent student. How would you describe to them, okay, they're just given this 4x plus 2y equals 8. How could they possibly transform it into an equation to graph? How could they graph that equation? Okay. Pause here. Okay, so first things first, we need to convert the equation to slope-intercept form. And then graph our equation. Okay. Our third activity today, we're going to see a few different examples that might look a little bit different than maybe our first example and things that we haven't quite seen a lot of lately. Okay, our first equation, I'm going to draw my line down the middle, isolate the variable. I'm trying to isolate that y variable. So first I see an x here, so I'm going to subtract x on both sides, and I'm left with -5y. Remember, this minus sign is still here, so I need to carry that down. It's really -5y, okay? Equals, I can't combine these terms, so it's -x plus 10, okay? And now my next step, I would like you guys to try to do the rest on your own. I got you started, so pause here, see if you can figure the rest out and try to graph this equation. Okay, let's see how you guys did. So we're going to divide by -5 because that is the number that comes right before our y. It's our coefficient. So we got to divide by -5 because I don't want -5y, so I just want what 1y is equal to. So we're going to divide every term by -5. And I get y is equal to, this is where some of you guys get a little confused and maybe just are in the zone and you make little common mistakes. So if we look in front of this x, there's really a 1 here. So this is really -1 divided by -5. Some of you probably automatically put down +5. That is incorrect. That would be if it was -5 divided by -1. This is the opposite. So we really are doing -1 divided by -5, which if you look over, we can see is really +1/5. So our slope is actually +1/5 x. And then if we look at our y-intercept is 10 divided by -5, which is really -2. And you can either put plus -2, put -2, all of those are totally correct. So to graph this, we're going to first plot our y-intercept like usual. And our slope is rise over 1, so we need to go up 1 over 5. Up 1 over 5. Keep that pattern going in the opposite direction. And connect our points. Hopefully better than I just did. Okay, so that's example 1. That one's pretty straightforward, but I wanted to give you guys an example where you don't see the coefficient of x. You need to remember that that is always 1 and expose you to a little bit more fraction slopes. For example 2, this one's going to be very, very different. So I need you guys to pay very close attention. If you look, there's something very different about this example, and that is we have an x on both sides of our equation. This is going to end up not mattering too much because what I'm going to do is I need to first, to get my y by itself, I would subtract x from both sides. But if we look, we already have an x on this side. So if I have x minus x on this side, that cancels out. I'm left with 2y. But same thing over here. I have an x and I'm subtracting an x. 1x minus an x is going to give me 0 x's. So I'm really left with 2y is equal to 8. Okay, my x's just disappeared because I subtracted 1 from both sides. Okay, now my last step is to divide by 2, right? So this is like a regular equation. I'm left with y is equal to 4. If we look back up to this one, we kind of talked about what y equals is. Y equals is going to be a horizontal line like we talked about right up here. Okay, so I need to find all of the points where there's a y coordinate of 4. This point is 0, 4. This point is 1, 4, 2, 4, 3, 4, 5, 4, 4, 4. And all of these points on this horizontal line are going to have y coordinates of 4. So this is going to be our line of y equals 4. Another way that you guys can think about it is this is the same as y equals 0x plus 4. My slope is 0. I'm not increasing or decreasing. I'm staying constant. And my y-intercept is 4. That's just another way you can think about it. 2 different ways there. Okay? If I were you guys, I would put maybe a little star next to that one. You might see something a little bit similar come Friday. And we're going to move on to this next one. Again, we're getting more complicated. This isn't just a 2-step anymore. We're leveling up, as they say in video games, right? So when we see parentheses, we're going to need to use our distributive property. I would like you guys to try to pause this, okay? And just do the distributive property, okay? Don't do anything else because we're not too familiar with equations like this, okay? So do the distributive property and then come back to me after you're done with that. Go ahead and pause. Okay, so with the distributive property, we're multiplying the number outside of the parentheses by the numbers inside the parentheses. So I'm going to multiply 2 times y, so 2 groups of y would be 2y. Then I'm multiplying 2 times this negative x, so I have negative 2x on this side. Now, normally I would add 2x to both sides, and things like that. I'm actually not going to do that this time, and this is a special reason because I am noticing that I have two y's on both sides of my equation, okay? When I see that, I know that if I subtract 2y from both sides, they're going to cancel each other out. So this is going to be kind of like this one where we got y is equal to a number. This is actually going to be a vertical line where we're going to get x is equal to a number. Okay, so because I see this 2y on both sides, the exact same term on both sides, I'm going to subtract that on both sides because I know it's just going to get rid of both of those terms, and I'm left with negative 2x is equal to negative 14. Okay, so we got to be kind of observant here. Now I can divide both sides by negative 2, and I get x is equal to negative 14 divided by negative 2 is 7. So for this one, we're plotting all of the x coordinates that, or all of the points that have an x coordinate of 7. So this is 7, 0, 7, 1, 7, 2, 7, 3, 7, 4, and all of these points are going to have x coordinates of 7. Okay. So like we said before, x equaling a number is going to be a vertical line, just like we saw here. Okay. Maybe something to also look at before your check for understanding. Okay. So that is the bulk of our lesson today. I want you guys to really try these practice problems. I will be grading these on effort. So if you're trying them out, even if you get stuck, you can move on. It's totally fine. Ask Miss Cater. She's going to be around. If Miss Cater's not around and you need to ask a dire question to somebody, you can go across and ask Miss Retzler. She would be happy to help you. Remember, I'm going to post the answer key to all of our practice problems on Thursday night. Miss Cater is going to post it on your end grade for you. Okay? So look over your answers to these practice problems. It's only 7 of them. And then if you finish before class is up, we're going to do some IXL practice based on exactly what we learned today. Okay? Be on your best behavior. Now that you have finished your lesson, you may listen to music while you practice, as long as you are actively practicing. And you guys have a great rest of your day. Okay? Go ahead and start with practice problem number 1.